Going to be talking about ratios in tables. And we will be making ordered pairs and graphing those ordered pairs onto a coordinate plane. So we talked about tables previously and how to understand what that means and how we can continue to make equivalent ratios using tables. So what we're going to do is kind of continue on the same thing. So today we're going to start with this type of problem, and we're making a salad dressing. And you can see here that for every 1 cup of vinegar, we would use 3 cups of olive oil. Now we can continue this for more batches of salad dressing using the table. So if we multiply by 2, right, we'd have 2 cups of vinegar and 6 cups of olive oil. And we're continuing to go up in the same pattern. So our ordered pairs would be what is in each row of the table. Now, with these ordered pairs, we can actually graph them. And so we're going to use our same information from our previous table right here that we have. And what we will do is we're going to place a dot on our graph where these ordered pairs lie. Now, previously, you've learned probably about coordinate planes, and you know that 0, 0, yeah, right? Which, if you're talking about an x and a y axis, that's where they meet. And we call that the origin. So we always start at the origin. And whenever we're graphing, we always go over first, then up. So think about it like an airplane. An airplane doesn't just take off into the air. It has to go over first and then up. So we are able to graph points by putting a dot where they belong. So this one, because the vinegar is our x coordinate, would be a 1, and our y coordinate is the olive oil, 3. We would put a dot here. And we can place the next points to continue on from our ordered pairs here. So 1, 3 was our first point. The second point we would have is 2, 6. So once again, I'm going to add another point, and I'm going to place it at 2, going over 2 and up 6. That would be our next ordered pair. Okay? And we can continue on in that method. 3, 9. Okay. And then our next one would be at 4, 12. We could put another one at 5 and 15 if we wanted to keep going. So we are then able to see kind of how our ratios are equivalent. And you can see it goes in a nice straight line, so that means it is equivalent. We can then take a look at the graph as a whole and see how it matches up with our table. So as you can see, first ordered pair 1, 3 is here, 2, 6 is here, 3, 9, 4, 12 is here, oopsies, and 5, 15 is there. Now, they both illustrate the same ratio relationship because the points match up. Okay? And we can describe this relationship by looking at it and saying they're all equivalent, right? Because we're able to draw a straight line through them to see that it is increasing at the same amount every time as we increase the number of batches of salad dressing. All right, so let's go on to an example. Let's try this on our own. So we're going to graph these ordered pairs, 1, 6, 2, 12, 3, 18, 4, and 24 onto this coordinate plane. So we're going to do the same kind of thing that we did in the last one. So we're going to start with 1, 6. So I'm going to put a point at 1, 6, right there. Remember, we always go over across our x-axis first, then we go up through our y. Then we have 2, 12. So I'm going to put it at 2, 12. There's our next point right there. If we look back, we have 3 and 18. That goes right there. And finally, we have 4 and 24. There we go, good. And now we can see once again that we see a steady increase, right? This nice straight line that we can graph on our ordered pairs. And if we check it, we are correct, and that's how it should be. All right, go ahead and out of that. Now, what do you notice about these points on the graph? Well, when we look at them, we see that it's a nice linear line, right? Straight line. Everything is increasing at the same rate, which means these ratios are all equivalent. 1 to 6, 2 to 12, 3 to 18, 4 to 24. They're all equivalent ratios because we have that straight line. We're going to skip that extra example. That's okay. We're going to graph now and interpret ratio relationships. So when we were doing this, what we're going to do is we're talking about a batch of homemade modeling clay. It's used in arts and crafts. Sequoia mixed the ingredients shown in our table. We're going to graph the relationship between the number of cups of water, which is our Y, and the number of cups of flour, which is our X. So 4 to 2 will be our relationship. Now, when we talk about this, what we're trying to think about is, how do you know that the relationship between flour and water is a ratio relationship? So that's what we're thinking about. Now, whenever we talk about recipes and doubling batches and all that, and tripling and quadrupling, if you're making more than one batch, we always want to think about it as a ratio relationship, because what we do to one thing, we always want to do to the other, okay? We need to keep it equal. Remember that balance scale, okay? We want to keep it balanced. So the first thing we need to do is generate a set of ordered pairs. Well, remember we had a flour was our X, which is 4, and our water, which is Y, which is 2. So 4 to 2 for one batch. Now, if I'm going to have 8 here for our flour, what are we doing? Well, if we're making 2 batches, we're doubling it, right? So in this box, I'll just use my pen here. If we're doubling this, right, this is times 2. And I like to write on my tables so that I can kind of keep my thoughts in order and know what I'm doing for each step. I'm going to also take this times 2, okay? So 2 times 2 would then be 4. Now, does this look like the same relationship? It does, it should, right? This is half of that, right? This is half of that. And we're continuing to do that. Now, if we're doing 3 batches, right, we're going to go times 3, right? 4 times 3 is 12. So 2 times 3 would be 6. Now, if we're doing 4 batches, we're going to take this times 4, right? So 2 times 4 is 8. And finally, this last one should be a times 5, right? Because we're doing 5 batches. 2 times 5 is 10. Okay. So that should be what our ordered pairs would be. 4, 2, 12, 6. And remember, when we write ordered pairs, we put parentheses around them to tell us these numbers need to stay together. They are representing one point together. We then have, what did I miss? Oh, I missed my 8, 4. 8, 4, 16, and 8. And finally, we have 20 and 10. All of these represent the ordered pairs that we would use for this table. Oops, that's not what I wanted to do. Sorry, I'm going to go back over here. Now we can go ahead and graph those. Using those ordered pairs that we just wrote from our table, we can graph it along our coordinate plane. So we start with, oops, let's go back, come back. Here we go, 4, 2, and then 8, 4, right? I'm just gonna use my pen because it's easier. So that 4, 2, right? That's my first point. This is 4, 2. Then the next point was 8, 4. And then we had times 3, right? So that would be 12 and 6. Then we had 4, which was 16 and 8. And our final point would be up higher. So we'll just graph those ones. Now, if we were to take a look at these, does this describe a ratio relationship? Well, can we draw a straight line through all the points? If I could draw a straight line, I guess. I don't know. Sorry. But we can draw a straight line that would connect all of our points, which means, once again, this is a ratio relationship. We're increasing the same amount every time for both of our pieces, right? Both the water and the flour. Now, we can describe the pattern, okay? Here's what we know. We can see this linear relationship. We can see that it matches up with our graph here. So it says in the graph, the points appear to fall on a straight line. Each new point is 2 units up and 4 units to the right from the previous point. This means that the number of cups of water increases by, well, what do we increase by? Cups of water we increased by 2, and the flour we increased by 4 every single time. Which makes sense because one batch is 4 cups of flour to 2 cups of water. So it should increase that much each time we move through. So do you think that all ratio relationships will have graphs that appear to fall on a straight line? Why or why not? Well, remember what I said, kind of the proof of this is they are falling in a straight line. We can tell that because they are increasing the same amount every single time. So yes, this is true. This is a ratio relationship because we can see it fall in a straight line. So it should. All right. Ooh, there's my bar. There we go. So that is it for today's lesson. Remember when you are graphing that we always go over first, then up, right? Like an airplane. We can't just take straight off. We have to first go across the runway before we can lift off into the air. So that's the biggest thing to remember when graphing the ordered pairs. Remember again, brackets, right? Parentheses around your ordered pairs when you are writing them. Helps to keep the two numbers together so that we remember these two belong together. And finally, ratio relationships do fall in a straight line. That's kind of the proof that it is a ratio relationship, increasing the same amount each time. All right, as always, if you have any questions, please let me know. Have a great day.